When given raw data, one of the first questions we kind of need to decide is whether or not excuse me, the data follow a normal distribution. In this set of data here on the Federal Trade Commission on different types of cigarettes, we have tar content here of, I think, maybe 500 cigarette brands. And the question is whether or not these data follow a normal distribution. Now, we could answer this question using graphs. So if I look at a histogram, simple histogram, looking at tar data, click OK, and it's kind of hard to tell from this histogram whether these data are normal. Let's see if we can clean this up a little bit. Minitab has used quite a number of bins. If I double click here, I can go in and edit the binning. What's it used? It's used 27, I don't know. Let's see if I use 15, whether I'll be able to tell. Okay, it's still a little bit difficult to tell. It looks like these data have a right skew to them because this area over here looks a little bit longer than what's on the left. Okay, but that's kind of subjective. Another graph we could do is, where am I? The box plot. Simple one, tar content, and there are 5 outliers. Anytime a set of data shows outliers, it generally, but not always, indicates non-normal data. Now, with the exception of these 5 data points, the rest of this distribution looks fairly symmetric. The whiskers are, they're almost the same length, and the bottom half of the box and the top half of the box are roughly the same, although I will admit they're not identical. But again, it's a bit of a hard call to tell whether these data follow a normal distribution. So a little more formal way is to again go back to the graph tab, and we're going to use something called the probability plot. And as I pointed out in another video, be sure to distinguish or take note of which one you're using, the probability plot or the probability distribution plot. Now, probability plot is going to tell me whether my data follow a particular distribution, and in our case we're interested in whether it follows the normal. Alright, click on this thing. I'm going to give it a single set of data. I give it the data, and I don't really need to do anything here except click OK, but just to show you, Minitab is going to check by default whether these data follow a normal distribution. There's a whole bunch of other distributions you might be interested in, but we're not interested in them in this course. So, okay, we want to know, do these data follow a normal distribution? Click the OK button. And what I get here is a plot in which my tar content is being graphed down here on the x-axis, and on the y-axis Minitab calculates basically the percentiles that each of these data points represent. If these data did follow a normal distribution, all of these blue dots should fit between the outer red bands here, these confidence intervals, and if they were perfectly normal, they would follow along this middle red line. Now clearly they don't. They've fallen off the wagon down here on the low end, and they've certainly fallen off the wagon up here on the high end. But again, this is a little bit subjective. But if I look at the data in this box right here, it tells me, by the way, that it's carried out the Anderson-Darling test, which is what the AD stands for. There's 500 data points in here, and the p-value is given as less than 0.005. In your notes, it says, if the p-value is less than 0.05, the data do not follow a normal distribution. Since our p-value is even smaller than 0.05, in fact it's smaller than 0.005, we would conclude these data do not follow a normal distribution. And p-values give us a little bit more confidence, I guess, that the data either follow the normal distribution or they don't. And in this case, they clearly don't. So this is another way, again, that we can determine whether data follow a normal distribution. And this is a little more statistically correct method than simply using a histogram or a box plot.